Hi, for today's teardown, the Ferranti scanning doppler antenna from the Westland Lynx helicopter. So it is my first ever radar antenna. Obviously quite large. This dish is 75 centimeters long. I got it on eBay for 30 British pounds, if I remember correctly, which is quite cheap. I do not know yet what I will do with it after the video, because there are reasons for keeping it and reasons for scrapping it. Why I should keep it? First, because it is cool and it is my first ever radar antenna. Why I should not keep it? Mainly because it is taking up a lot of storage space, and also because it is in quite bad condition. As you can see, the mesh here is all oxidized, everything is rusty, we have damaged parts, and actually it is not rare. I could get another one if I want. So I did not decide yet what to do, but today at least we will have a look inside. As you can see, we have a base piece here which is attached to the airframe of the helicopter with connectors. We have the main radar dish, which actually can move like this. It should be, by the way, very noisy when running. And we have the rotating part, but it is locked in place by the mechanism. For now I cannot rotate it. I believe it should turn something like 120 degrees, something like this. There is no reason for it looking backwards through the helicopter, obviously. So it is just the radar antenna. So we have the dish, we have the microwave horn, we have all the mechanics and electronics to control the movements. Here I believe this very destroyed piece must be the remains of the pickup for monitoring the output power. We will have a better look at it later. But we do not have in here the actual radar transmitter and receivers. They are external and normally connected to the waveguides here. We have all the nice mechanism here. So where to start? We'll first have a look at the information stickers, I believe. First thing to do. So sorry, most of them will be upside down because of a very particular shape of a device. Here we have the scanner sub-assembly radar, serial number 237 with a NATO stock number. Quite a few modifications were made, 5 apparently. We have here the two waveguides connectors, which are at an angle like this with these clamps to secure the matching waveguides. We have here the latches to close the bottom cover. They work like this, quite a particular model. You have to open like this and lock like this. This one is extremely rusty, by the way. Here I believe it is an attachment to attach the device to the radar, to the aircraft airframe, but here we have also all for a big bolt, which I do actually have. I did remove them because they were super rusty. Okay, little cover here with some electronics behind, but first this top assembly here is called the reflector antenna. It has its own serial number. So it is made of an aluminium mesh, as you can see, glued to a carbon fiber structure apparently, with honeycomb filling. Here, excuse me, you can see this part is damaged. It did rub against something and the mesh is unglued. But on the other side, there is actually here a hole in the structure, and you can clearly see the honeycomb pattern inside. So this assembly is actually pretty light when you undo it. Really, it is not heavy at all. On the whole, radar assembly is not that heavy. It must be like 8 kilos, something like this. So here we have something interesting. We have the motor for the elevation movement. This one is called elevation, the other one is called azimuth. As it is written on this lock pin I found to secure, it goes in here to secure the movement, but it is actually already secured by the mechanism, and it is completely impossible to turn it anyway. So here we have the motor for this movement with a gearbox. Pretty long motor assembly, some feedback sensors. I will remove it later and we will have a better look at it. More interconnects here, a lot of them actually, like this, little terminal boards, because here we have a gyroscope that will be probably a separate teardown. I will unsolder it and we will take it apart in a separate video because it is a quite cool little unit. Interesting sticker here about warning hazardous voltages present on tag strips. So it is apparently how they call these things, tag strips. I should, usually they are called pin terminals or terminal something terminals, but tag strips, I did never see it before. What else? Here the main equipment sticker, so you can see it is Ferranti made. It's called a scanner radar, and here we have a warning about remove 0 pins before installing equipment, so it is exactly this thing. There is actually provision for another one here, which I do not have, but it is how I lock this movement with this one. And here they did also provide some kind of screw you can unscrew and it will lock in this hole. We have another sticker here just for this assembly. So here you can see the detail of mesh. On the arm assembly, actually we have this part with this that is completely broken and unglued. I will remove this arm and we'll have a better look at it and maybe even open it. Here we have a completely destroyed assembly. You can see this is the remains of a rigid coax that was apparently connected in here to a little electronics box that goes with a wire inside here, but it is completely broken and missing parts. So I believe it is the pickup for the power monitoring. Another model reference sticker here with another serial number just for the horn waveguide. The screws on this thing are annoying. Apparently they are a mix of imperial and metric because the heads are imperial, but it looks like the thread is metric, which is super weird. We have here some kind of a moisture absorber device. We will have a better look at it later. And we have two main electrical plugs which are in very bad condition. You can see this one how it is completely rusty and oxidized. And this one, actually I did replace the ring here because it was broken. I found one in my stock, a matching one, but it was missing the nut. Well, it was 3/4 of a nut, completely oxidized. Okay, we have here the main cover covering actually the connection between the fixed and the rotating part. Not the waveguide connection because it is in the bottom assembly, but the electrical connection to the motors. Okay, so it is a first view. So now I believe the first thing I will do is to undo the dish on the arm because they are completely in the way and the thing is taking an awful lot of space on my bench. It will be much easier to handle without them. So this dish is actually the only easy and quick thing to take apart of this radar, because everything else is super annoying, except maybe for the bottom cover, but this dish is very quick to undo. You have here some kind of a counterweight on this side, because actually we have a lot more weight on this right side, so we need counterweight here. And we have two bolts to undo each side with 7/16 and 5/16 inch keys. Yes, they are completely weird size of Imperial hardware. Quite insane to do such, even think about doing such sizes of hardware. With me, I will secure it here. So here we are. It is off. This assembly is super light, maybe 300 grams, something like this. 500 at max. Really, really light. Quite interesting. And now it is freeing up a lot of space, and I will also undo the arm assembly, which is poking out here. But for this I have to undo all these bolts and these screws, which are actually securing the waveguides inside. So I will do it for you. Okay, much better. It will be a lot easier to handle without this assembly, so we will have a look at it later on. But as you can see, it will be a lot more convenient. And in here you can see the two waveguides. So I believe one is transmit and one is receive. Going to this assembly, we will open it because I believe we have some stuff inside. Now I can start to undo some of the covers before we pop open the main cover. So let's do it. So here on the top we have an access panel. Actually it is just an access panel to the circuit cards connectors inside. There is a card cage with 3 circuit boards, and it is just the rear access to the connectors for them. Nothing in particular to see at this level. It must be just for manufacturing purpose they did provide this panel, but or maybe to access some of the wires and do testing, but it has no real utility, so I will reinstall it immediately. So I will be done with this one. So on the side here we have a cover covering 4 power transistors. One of them is made in Britain and is very rusty. The other ones are not so bad, 2N series. There are 2 screws here for something inside, so I will not reinstall this cover immediately. Maybe it will be useful for me to undo the screws. And here we have another cover covering 2 devices called the Beckman Heliport Div. They are hybrid devices. I believe they are motor drivers, and these are actually very common parts in aircraft equipment. If I happen to scrap the device, I will crack one of them open. And here we have the cover covering the clock spring connection to the rotating part. So it is like the one on in a car, on a car steering wheel. You have a big flex ribbon spooled like this, and it will allow some part to turn. You can see it is connected here with a large connector to the wire loom going inside. We have here micro switches for the end of travel contacts of the rotating part. And the screws here are actually very important. They are securing the mechanism inside the motor. Here is what looks like the cover. As you can see, here there are 2 screws with a spring-loaded washer that will actually engage in these slots here to secure the cover in place. This cover has another half, but it is not necessary to undo it. It is exactly the same thing. And yes, here the broken electronics module that I will need to undo to show you. Okay, now I believe it is time to undo the main bottom cover. So very quick to undo, just for things to latch here, and should be able to undo the cover. That is empty except for the moisture absorber cartridge. And here is what we have inside. Oops! It is still quite easy, this assembly. So we have the main area of interest is of course this rotary waveguide assembly, but I do not think I will take it apart too far away because it should probably be quite a pain to reassemble, but I will demonstrate it after removing the motor here. I will be able to rotate the antenna. Here we have the electronics with more electronics here and here. So 3 circuit boards, some kind of transformers here, and there are more stuff hidden here at the bottom. We have here our meter. It is showing 1789 hours. Coincidence? I do not think so. It is the year of discovery of USA, well, America. And we have a shielded box here. Okay, I believe I can now install the camera overhead, and we will start to have a detailed look at everything. So we will start with quick and easy parts. Here the moisture absorber, briefer desiccator by Brownell Limited in London. We have apparently a plastic cover, so I believe it is a unit you can swap easily and maybe refill, because here if I undo this part, okay, you can see everything is oxidized on the screws Luckily, no screw is completely stuck, but some of them were pretty hard to undo. We have some kind of a filter like this, attached with a spring, like so. And it is, by the way, very annoying to install, but you get the idea. And here we have an internal cover, and inside actually some silica gel or something like this. So I believe this unit you can unscrew it and replace it easily, but it is stuck for now. But and there is some kind of an indicator here that shows if it is still good or not, it seems. Oh, I did forget about the bottom stickers. Here they are. And electrosensitive parts, electrostatic sensitive parts. So this is the first thing. We will continue with the completely broken electronic assembly that was under the horn. You can see I had to cut the wires because actually to rotate the radar antenna, because it was completely stuck, and the only way was to, for me sadly, to cut the wires and remove this unit to be able actually to undo the cover here. So here we have circuit board with a few very bad capacitors, obviously, and broken box. I believe we had a coax connector mounted here somewhere to actually connect the broken coax pipe here. And what do we have inside? So you can see the condition of the screws. They are really not that great. I hope I will be able to undo them. There is white powder falling when you undo the screws. But I would like to show you what we have inside here, because actually I have not seen it myself already. Very annoying, and you know what, I will need to undo, I believe, 2 more screws inside. Oh no, it's good. Okay, so we have apparently this little circuit board with a few transistors or integrated circuits. So it must be some kind of amplifier, preamplifier, something like this. And I believe it is the power feedback monitoring of the radar transmitter. So nothing particular here. Okay, we can go to the next part. So the next part will actually be this horn. You can see how it is made. I just want to open here this top half to expose what we have inside, but it looks like it will be quite tedious, so let's do it anyways. So it was just super difficult. I should now be able to pry open the two parts here and show you what we have inside here, at least. Oh, no, because there is still one stuck screw in the hole. Okay, so here is what we have. You can see we have two channels going directly from the waveguides to the end of the arm here, and we have a separate channel here in which we add these two things. So here it looks like it is just the end of the coax cable acting like an antenna. This might be a dummy-load or something like this, terminator. And this is a completely separate channel except for one hole here. So obviously we have microwave high frequency magics happening in here. Quite interesting. And you did see how difficult it was to take it apart. And this part did actually fall from somewhere. I do not know where it was. It would be interesting to actually figure out where it was located. Maybe I will find it when watching the video, because for now I have no idea. Wait, it may be here somewhere. Quite interesting. No idea where it was located. No, here maybe. Really curious. Okay, so I will put all these parts aside. It will require a tedious reassembly later, obviously, because as you can see it is very painful to undo, and will be even more painful to reinstall. And for some reason now it will not even align properly. Very interesting. Okay, I will do it off camera later on, but as we are busy with waveguides, I will now open the main top cover here, and we will have a look at what we have in here. It is just waveguides, so it will be quite straightforward, but it is necessary to check anyways. Okay, screws are undone, and behind this very rusty cover here is what we have, just two flexible waveguides. Not sure why they made them flexible, because they are not supposed to move whenever the horn is secured in here. You can see the wire loom here going inside to the clock spring. Actually there is I can see a connector here at the bottom, so the clock spring has two connectors, which should allow to replace the flat cable completely. And you can see here the rigid part of the waveguides going at the bottom to the rotary waveguide connection. To demonstrate the rotary waveguide connection, which I will do right now, I need to, excuse me, this thing is completely oversized for my bench, it's quite awful in fact. I need to undo this motor assembly here at the bottom, which will be pretty quick. It is just one connector and 3 screws. So I believe there is some kind of a clutch inside this motor, because it is completely not possible to turn the moving part whenever it is installed. be some, I must be careful with my screens at the back. You can imagine how is this thing is awful to work on. I believe in the factory they had a special attachment for it, but really on my bench I will take hours to put it back together, while I can do it while the video is rendering at least, or start to do it. Okay, this assembly is off, I will show you it later. But now I can actually rotate the antenna. Here is one dead end, so can I unzoom for you? No. I will put it, I believe, oops, excuse me, horizontally. So maximum position in one direction, and in the other one, so it is a little bit more than 180 degrees, maybe 190, something like this. And you can see whenever I turn, the clock spring here is unspooling, and it is normally secured by this cover. It is why there is oops, the piece here inside the cover to secure a little bit more clock spring. Okay. About the rotary waveguides, so here I will not be able to see much, but if I, oops, excuse me, rotate it the other way, here you can see we have two waveguides, so there is two levels of connections. You can see there is another one at the bottom here at the, and I'm not sure exactly how they do it, but it is a transition between this rotary part, this attached one, and another time here. Quite interesting. Everything is secured under this cover. There is a big gear here to the mechanical connection, as you can see, to the motor drive. Okay. This is pretty insane. I will take the opportunity of having taken apart one of the motor drive to undo the other one here, and we will have a look at both of them right now. The gyro assembly in here, it is just secured with 4 screws and a few wires to unsolder, but as I said, it will be a separate teardown this thing. It will be a much easier and quicker teardown for sure. So I will be right back after I undo the motor assembly here. So about these assemblies, the azimuth and elevation motors, here is what it is called for this one. There are some wires going inside, 3 wires, so I am pretty sure we have a micro switch inside. Probably secured here with maybe even an adjustment here, but I am not sure of what will happen if I undo these bolts, and maybe I will not be able to realign properly the bearings or something like this. And this teardown is tricky enough, so I will not undo it. But we have here wire loom with a servo motor tachometer generator by Muirhead Vactric Components Limited, as you can see, in Buckingham, Kent. So most probably this is an assembly. You can see how it is super long. I believe this is just a gearbox again. And the proper motor is here. Here are the specs for you. Quite a lot of connections actually to this thing. And there is here what seems to be another device. Maybe it is a synchro transmitter or something like this, but there is actually too many wires for a synchro. It should be 5 wires. And here we have 6 and 3, so it is a total of 9 wires. and it looks like the label is completely gone on this thing, so we'll not be able to know what it is. Okay, it is the first assembly. This one, the azimuth assembly. Actually, we have more or less the same thing, but a lot less connections. We have this thing here that looks like a gear, but it is not quite well. Maybe it is a heatsink. And here also the label is erased. I can read again tachometer something. City Products Corporation, Illinois, USA. But it is completely erased also. Here we have two devices, not one. We have one Pinion Gals, probably multi-stack precision potentiometer. Yes, 180 degrees it is written on here. A stack of 4 potentiometers apparently, with its own serial number. I did not find a needed code so far in this thing. And here we have apparently the same device than we have here, with the label not erased, but hidden by the wires. Resolver compensated resolver apparently, made by Muirhead also. Okay, I hope I was in focus. This is called the motor gearbox azimuth. And yes, I was actually right. So this one is the azimuth and the other one is elevation. Okay, but as I said, this thing is more or less completely stuck. So I'm not sure what is happening. You can see actually the motor part will turn, but the main gear here is completely stuck in place. So maybe it is a bad bearing or something like this. Quite interesting. And you cannot, we have a 144 written here and here. It looks like a serial number, but finally no, the serial number is 133 as written here. Okay, quite interesting. I will put back these things on the radar, and now we will have a look at the electronics. So, about the electronics, we have first this box here with apparently filters to the outside world. I believe this box will be easy to open, but I did check in it and actually we have nothing except wires. You can see the interesting multi-layer interconnects here, terminals of some description. And this box is just apparently power input filtering or something like this. Quite well shielded. We have at the bottom the main connector that is actually outside of this box. So in here we just have one potentiometer, maybe no, not potentiometer, maybe transformer by Ferranti, a board with a few capacitors, more interconnects, the back of the connector which is completely oxidized, and it is all for this thing. I was expecting more interesting stuff. You can see this one still has its locking wire. Quick look at the side on the elapsed time indicator module. 400 Hz, so I said 1769 hours. Okay, I will reinstall this. On the other side here, we have an interesting assembly. Actually, we have here two big transformers, but there is something else at the back. I will try to show you, if possible. Oh, okay. So working on this thing is just a nightmare. It is probably the most tedious and difficult video I have ever done. And I have a lost screw that is somewhere in here. Excuse me, I need to undo two more screws and try to show you what we have in here. Okay, in here, how will I proceed? Maybe like so. We have actually more transformer, and we have an assembly with two synchro resolvers and transmitter. It must be some closed loop, feedback loop, because there is no, I do not see any mechanical connection to them, so probably it is just two gears, and they are connected one to the other. Something like this. Quite interesting, so it must be for keeping track of a relative position or something like this in a closed feedback loop. We have one more transformer like this one, so I believe they are branded Ferranti somewhere, not sure. They are obviously transformers because you can see the core here, the stack of plates. And it is all. Here we have also the connections to the helipod devices, one more terminal strip, and some wire looms going all at the bottom with a connection to the transistors, and it is all. You can see the circuit board's cage is closed with two pieces of clear plastic for some reason. Okay, I will try to reinstall this, find the lost screw, and then we will have a look at the circuit boards. So, the circuit boards will actually, I believe, conclude this video. Here is the first one. I can see that code at least of 79. It is called the amplifier electronic control for elevation. So control for the motor, apparently, servo control of the motor. Nice conformal coating, mostly transistors and capacitors and resistors. We should have a very similar one for the azimuth. Actually it is this one, but it is not similar at all. It is very much different. We have shielded radar, shielded relay here, another one here, ZN5400 integrated circuit, very bad sticker here, as you can see. Some interesting bulb wires here. They were not able to route the tracks apparently, and they had to use bulb wires. Last board is called the power supply subassembly. Obviously this board was hot. You can see the power resistors here did burn through the glass. Some interesting diodes here mounted on little brackets that are actually riveted to the circuit board. No bulb wires, but very bad oxidation here on the connector. Okay, so not a lot, big deal of electronics in this radar, just servo controls and power supply. but you get the idea. Now I have a few screws to reinstall, and hopefully try to edit this video and do something not too bad, because it was super tedious to shoot. So I will do my best. So thanks for watching, bye bye.